In this video, we will learn 10 numerical questions. The book is Concepts of Physics, Volume 2, and the chapter is Electric Field and Potential. Already in previous videos, we have completed question number 1 to 10, 11 to 20, 21 to 30, and 31 to 40 in 4 different series. In this video, we would be doing question number 41 to 50. Question number 41 is saying that a 10 centimeter long rod is there which is carrying a charge of 50 microcoulomb. The length of the rod is given 0.1 meter or 10 centimeter, and the charge which is being carried by this particular rod is 50 microcoulomb, which is distributed uniformly over its length. The question is, find the magnitude of the electric field at a point 10 centimeter from both the ends of the rod. This is the distance from both the ends. If you're taking the distance from point P to the point P, it is 0.1 meter. We have to calculate the field at a particular point P. For this particular question, we have to take the formula which is there for electric field due to a charged rod, and that is 1 by 4 pi epsilon naught 2q upon r, where r is the perpendicular distance from the rod to the point, root over L square, where L is the length of the rod, plus 4r square. If we put all the given values here, 1 by 4 pi epsilon naught, 9 into 10 raised to 9, 2q is 50 into 10 raised to minus 6. The distance, perpendicular distance from the rod, that is 0.0866. 0.1 is the length square plus 4 into again r square. On simplifying this, we will be getting the electric field as 5.2 into 10 raised to 7 Newton per coulomb. Because it is positive charge, it will be away from the rod. Question number 42 is there, saying that consider a uniformly charged ring of radius r. Find the point on the axis where the electric field is maximum. Again, whenever we are talking about like force is maximum, field is maximum, this kind of question already we have done in one of our previous videos, where we had to find the maximum force, find the distance where force is maximum. Here the question is, find the distance where field is maximum. We have to calculate the field at that particular point, then we have to take the differentiation, and we have to take the differentiation is equal to 0, and we can find the value. There is only one way. So let us consider that there is a ring having radius r, charge q, and there is a point P at a distance x from the center on its axis, where we need to calculate the field and then maximum field. So first let us calculate the field. The formula is 1 by 4 pi epsilon naught qx, x is the distance, upon r square plus x square power 3 by 2. 1 by 4 pi epsilon naught we can take k, because we have to put many times, so better take k, qx upon r square plus x square power 3 by 2. Now the question is, find the distance where electric field is maximum. Electric field is varying as x is going to change. So we need to differentiate this electric field with respect to x, that is dE upon dx is equal to 0. And there is a formula to differentiate these terms. We have discussed in previous videos as well. If there is a term taking p by q, like u upon v, so differentiation of u upon v with respect to x, first we differentiate a numerator, denominator we keep constant, put negative sign, differentiate numerator, numerator keep constant, upon denominator the whole square. So that's what we have done here. You can see in the formula of electric field, kqx is the numerator. So kqx would be differentiated with respect to x. So x will get cancelled, it will be kq, and denominator would be written as it is. So r square plus x square power 3 by 2. Then negative sign, kqx would not be differentiated, it is written as it is, but r square plus x square power 3 by 2 we have to differentiate. This is the differentiation of function. So differentiate once with respect to r square plus x square, which will be nx to the power n minus 1 pattern on, and then power would be reduced by 1, and the multiplier would be 3 by 2. Then remaining r square plus x square would be differentiated with respect to x once again. So r square would be 0, differentiation of r square would be 0, and differentiation of x square would be 2x. So that's what is written there in the numerator of this particular line as dE upon dx. Now denominator is nothing but the denominator square, that is r square plus x square whole power 3 by 2 whole square. So that 2 and 2 would get cancelled, and it would be r square plus x square whole cube. If we are going to take this equal to 0, we know that denominator is not equal to 0, it means numerator has to be is equal to 0. And then if it is equal to 0, we are taking the negative terms or the half of the terms which are negative to the other side. The kqx, a kq term and kq term would get cancelled, and then equation would be coming r square plus x square power 3 by 2 is equal to 3x square. We can find the value of 3x square, and it would be r square plus x square is equal to 3x square, or 2x square is equal to r square, or x is equal to r by root 2. So on its axis from the center, if distance we can manage 1 by root 2 times to the radius of the ring, we would be having field maximum at that particular point. This is the formula which I was talking about, that if differentiation involves a particular quantity having u upon v form, then differentiation of u with respect to x, v must be kept constant, then dv upon dx, u is constant upon v square, that is denominator square. Question number 43, a wire is bent in form of a regular hexagon and a total charge q is distributed uniformly on it. Regular hexagon means it would be 6 sides, all of 6 will be equal. If q charge is equally distributed, uniformly distributed, then each side also would be having same amount of charge. Let us consider that because of one particular side, because in question it is being asked what is the field at the center. Without any knowledge also, if you have the knowledge about the cavity or field inside a particular closed conducting material, it is 0. Anyhow, this is the regular hexagon, it is a wire. Inside electric field is going to be 0, or at the center electric field is going to be 0. But let us consider that each side is having equal charge, that is some q upon 6, and because of that at the center electric field will be like this away. But when we talk about the field due to its opposite side, it will be again in opposite direction, so they will be cancelling each other. Similarly, if we take this side and this side, their fields would be cancelling each other. Similarly, if this side and this side, fields are going to cancel each other, and net field at the center we are going to have 0 over here in the question number 43. It is saying in the question, you may answer this part without making any numerical calculation. No need to calculate anything, as we know that at the center of ring also electric field is 0. Similarly, you can make the concept, or you can say the equal and opposite sides are going to cancel the influence of field produced or experienced by it. Question number 44, there is a circular loop of radius a, carries a total charge q which is uniformly distributed over its length. There is a small part dl is cut off. Find the electric field at the center due to the remaining wire. See, whenever these kind of question comes, we always take total field is equal to 0, because we know that when there is no part is being cut off, field at the center would be equal to 0. And if we can calculate the field due to small part, that is dl, obviously it will be positive. If it is the field due to the cut-off part, then same amount of field would be there because of the remaining part, but negative, so that when we are going to add this positive and negative, the resultant field at the center would be 0 over here. So we are going to take radius a, q is distributed over its circumference, that is total length 2 pi a, and if we talk about the unit length which is containing the charge q upon 2 pi a, so dl length would contain q upon 2 pi a into dl. This is the small amount of charge we can write as dq. Now we know that dq is a point charge. Field due to a particular charge or particular point charge is nothing but 1 by 4 pi epsilon naught q upon r square. So here it will be k, which is 1 by 4 pi epsilon naught. Obviously it is dq, small amount of charge, upon a, that is radius square. dq value we are going to put here as q upon 2 pi a into dl. Once we put this particular value, the electric field, because of this cutoff or the small charge object, will be 1 upon 4 pi epsilon naught q dl upon 2 pi a q. Now we know that field at the center is going to be 0. So two parts are there, one is cutoff part, one is remaining part. Field due to both will be equal to 0. It means remaining part is nothing but negative to the cutoff part, and cutoff part already we have calculated as 1 by 4 pi epsilon naught q dl upon 2 pi aq. Simplify it more, it will be q dl upon 8 pi a square epsilon naught into aq. That is the field due to remaining section of the wire. The question is saying, question number 45, the positive charge q is placed in front of a conducting solid cube at a distance d from its center. Find the electric field at the center of the cube due to charges appearing on its surface. We don't know how much charge is going to appear on its surface, but we do know one thing, that if q is placed here at a distance d on its center, q is going to produce some electric field, and that is nothing but k q upon d square. We know one more thing, that if it is cube, if it is ring, if it is sphere, if it is any closed charged surface, at its center electric field is going to be 0. But here some charge will appear on the surface of the cube because of charging by induction, if you take, to be more precise. So how much field that would be generating at the center? Obviously total field at the center would be 0, but this plus q is trying to stimulate some field at the center as kq upon d square away from the charge. It means same amount of field would be produced by the cube towards the charge, so that the center would remain in a situation of 0 electric field. So the field will be 1 by 4 pi epsilon naught q upon d square, but not away from the charge but towards the charge. That is what the answer of this particular question number 45. Question number 46 is there, where a bulb of mass 80 mg, 80 milligram, and it is carrying a charge 2 into 10 raised to minus 8 coulomb, is at rest in a uniform horizontal field. The field is given 20 kilovolt per meter, or 20 into 10 raised to 3 volt per meter. Find the tension in the thread. Look at the situation where charge we are going to take. It is at an angle theta. Because of this electric field, some force would be there on the charge, and we know that whenever a charge is placed in an electric field, force will be q into E, that is charge into electric field. Force is q into E. Force that is applied by the earth on the bulb because of its mass would be mg, that is force of gravity, it is mg. If we want to find the tension T, which is split or which is resolved into two rectangular components as T cos theta and T sin theta, which are going to balance, because the charge is going to be in equilibrium here. T sin theta is balancing QE, T cos theta is balancing mg. So if you want to calculate F, that is QE, it is nothing but 4 into 10 raised to minus 4 Newton. If you want to calculate mg, it is nothing but 8 into 10 raised to minus 4 Newton. It means mg is just double to the electric force. So for convenient in our calculation, I have written here 2F, means F is equal to 4 into 10 raised to minus 4 Newton. I have taken mg is equal to 8 into 10 raised to minus 4 Newton as 2F. Okay, because at equilibrium T sin theta is equal to QE or F, T cos theta is equal to mg. What now we are going to do, because we don't have to calculate theta here, so directly we can square and add these two equations, so that sin square theta plus cos square theta would be eliminated, it is equal to 1. So let's square and add. it will be t square sine square theta plus t square cos square theta is equal to f square plus mg square. It is nothing but t square, and f square itself and mg is nothing but 2f. On squaring it will be 4f square. So it will be 5f square in total. Now t is equal to root under 5 into f. Already we know the value of root under 5, 2.236. F value is 4 into 10 raised to minus 4. On multiplying it will be 8.944 into 10 raised to minus 4. Approximately you can write 9 into 10 raised to minus 4 Newton as well. That is the tension which is appearing in the string because of mg, because of the force, that is electric force in the electric field. Question number 47. A particle of mass m and charge q is thrown at a speed u against uniform electric field. See, if charge is thrown against uniform electric field and charge is positive, it will retard, that we know. So after some time it will come to rest. In this question it is being asked after how much distance it would come to rest. So let us take this is the electric field and this is the charge which is being thrown here. It will retard, it will come to rest after some time. If we are going to calculate the retardation or negative acceleration, it is nothing but F is equal to QE, that is the opposing force inside the electric field. So A is equal to QE upon M. Now we use the kinematical equation as V square is equal to U square minus 2S, because A is retardation here. V, that is momentary rest, after some time it will be 0. It is being thrown with initial speed U, and then minus 2 acceleration or retardation is QE upon M into S. So from here we can calculate S is equal to U square into M upon 2 QE. After this much distance the charge would come to rest. Question number 48. A particle of mass 1 gram and charge 2.5 into 10 raised to minus 4 coulomb is released from rest in an electric field. Field is given. Find the electric force and the force of gravity acting on the particle. See, if charge is there, field is there, electric force will be Q into E. That Q is 2.5, E is 1.2. So after multiplication 10 raised to minus 4, 10 raised to 4 will get cancelled, it will be 3 Newton. If we want to calculate force of gravity, it is mg, m is 1 gram, so it will be 10 raised to minus 3 kg, and then 9.8 meter per second square is acceleration due to gravity, so it is 9.8 into 10 raised to minus 3 Newton. That is the answer for the question number A, electric force and gravitational force. The question in the same question, next part is there, can one of these forces be neglected in comparison with the other for approximate analysis? Obviously, you look at the Fe, it is 3 Newton. You look at the weight, that is the gravity, force by gravity, it is 0.0098. So 0.0098 and 3 Newton. See, I'm not saying that it is very small value. We have seen the much smaller value than that. But if we compare 3 Newton to 0.0098, we can neglect when there is some approximity in the analysis. Now B part is there, time taken by particle to travel 40 centimeter. Look at this, acceleration will be there because of electric force, that is F upon mass. Acceleration is 3 into 10 raised to 3 meter per second square. S is equal to ut plus half at square formula if you are going to use. You put all the values like S as 0.4 meter, you starting with rest, so you will be 0, then half. A is 3 into 10 raised to 3 into t square. On solving it, we will be able to get the answer as 0.0163 second. So with this much high acceleration, it will be able to cover 40 centimeter of distance in a very small span of time, that is 0.0163 second. Now question number C is there. C part of this question number 48. What will be the speed of the particle after traveling this distance? Again, third equation of motion, v square is equal to u square plus 2as. V square is equal to u square 0 to a 3 into 10 raised to 3, distance is 0.4, and after calculation we will be getting this value as 49 meter per second. It is actually 48.7, but we can calculate 49 meter per second. The speed will be after traveling a distance of 40 centimeter. D part, work done by the electric force. Force is given 3 Newton. If displacement is known, we can multiply by the displacement and that will be the work done. So force 3 Newton, displacement 0.4 meter, and the work done will be 1.2 joule. So that is the complete solution of question 48. Now moving to question number 49. A ball of mass 100 gram having a charge 4.9 into 10 raised to minus 5 coulomb is released from rest in a region where a horizontal electric field of 2 into 10 raised to 4 Newton per coulomb exists. The charge is being released where some field is existing already. Find the resultant force acting on the ball. What will be the path of the ball? Where will the ball will be at the end of 2 seconds? So mass is there. Because of mass, some gravity force will be there. Because of charge, some electrostatic force is there. And because field is horizontal, electric force would be horizontal. And acceleration due to gravity is vertical downward. So gravitational force or force of gravity would be vertically downward. So in that situation, if we calculate electric force, it is Q into E is nothing but 0.98 Newton. After calculation, you can see Q, then E, and then simplify the calculation, it is 0.98 Newton. Then it is along horizontal direction. Then gravitational force would be 0.1 kg, 9.8 meter per second square, and it is 0.98 Newton. Obviously, it is vertical downward. So what is the resultant force? Addition of electric force as well as gravitational force. So F is equal to under root Fe square plus Fg square. Because both are same, we can take root under 2 into either one. So root under 2 into 0.98, and it is nothing but 1.4 Newton, and it would be at an angle 45 degree from either of the forces, like electric force or gravitational force. B part is asking, or B part is saying in the question, what will be the path of the ball? Obviously, if force is acting along a particular direction, resultant force that too, so body would be moving along the resultant force, and it is straight line or at an angle 45 degree with horizontal, at an angle 45 degree with vertical also you can write, no issues. Then question number C is saying where will the path, will the ball would be at a end of 2 seconds. Take the formula S is equal to ut plus half at square. So ut would be 0, half gt square, half g 9.8, t is 2 seconds, it would be 19.6 meter for gravitational due to gravitational force, that much distance. Then due to electrostatic force, again same distance, 19.6 meter. So if we want to find the total or the net displacement, again vector sum, and it will be root 2 into 19.6 or 27.7 meter, or roughly around 28 meter would be the answer of this particular question. Last question of the video. The bob of simple pendulum has a mass 40 gram and positive charge 4 into 10 raised to minus 6 coulomb. It makes 20 oscillations in 45 seconds. A vertical electric field pointing upward and of magnitude 2.5 into 10 raised to 4 Newton per coulomb is switched on. How much time it now take to complete 20 oscillations? See, if we take this as a simple pendulum, length of the string is L, mass is m, so because of the gravitational pull it will be mg. So in this situation, if there is no field present, time period is 2 pi under root L by g. That formula we know from the simple harmonic motion. Now if a particular field is there vertical upwards, so because of this field, what will happen? This charge is going to experience some force in vertical upward direction. And if it is going to experience some force, because of that force some acceleration will be there, and that acceleration is going to reduce the affecting g over there. G we know already, 9.8 meter per second square, but because of this upward acceleration it may be, and it must be lesser than 9.8. So if g is going to decrease, suppose acceleration because of this electric field is a, or electric force is a, then t is equal to 2 pi under root L upon g minus a. The time period is going to increase. So whatever answer we are going to get, obviously that is going to be more than 45 seconds, because without any electric field it was 45 seconds, g was complete 9.8, now g is going to decrease, so time period again is going to increase, because time period and g, they are inversely related. So if we want to calculate a here, it is q e by m, and it is nothing but 2.5 meter per second square. So now let us take the ratio of T1 upon T2 or T2 upon T1, because we have to calculate T2. 2 pi under root L upon G minus A upon 2 pi under root L upon G. So 2 pi gets cancelled. L and L will get cancelled. It is nothing but G upon G minus A. G is 9.8, A is 2.5. So final value it will be 9.8 upon 7.3. The ratio after taking the square root as well, it is 1.158. So T2 is equal to 1.158 into T1, which is 45 seconds. It is nothing but 52.11 seconds. Approximately we can take 52 seconds. So that is now the time period after applying an external electric field. Time period is going to increase because it is going to reduce the value of affecting acceleration due to gravity, and that is g. Thanks for watching.